Now that we know what a radical is, in this video we're going to take a look at how do we simplify radicals. And our goal is to take out as many perfect squares as we possibly can. But to do that, we have to start getting in the practice of writing our numbers, these will eventually be our radicands, as a product of a number and a perfect square. So in the first part of this warm-up, we're going to circle the perfect square in each equation below. So in the example, we had 50, that becomes 25 times 2, and the perfect square would be 25. In problem 1, we have 32, which is 2 times 16. 16 is our perfect square. In our second one, 9 would be our perfect square. And in our third one, same deal. So now we want to write our numbers that are down here as a product of the largest perfect square possible and another number. Now, obviously there are other factor pairs that we can have. Like for 12, we could multiply it by 2 times 6. But if neither one of those is a perfect square, that's not really going to help us. So I'm going to write this 12 as 3 times 4, 4 being our perfect square. 24 is divisible by 4. That's the largest perfect squares that goes into that. So that's 4 times 6. 200 is 2 100ths, so it's 100 times 2. 18 would be 9 times 2. 125 would be 25 times 5. And 108 would be 36 times 3. Again, there might be other pairs, but if we don't recognize the largest perfect square, then we're going to run into concerns later when we simplify. So when we talk about simplifying a radical, again, we're trying to take out the largest perfect square that we possibly have. So the radicals 2 root 3, 9 root 5, 6 root 11, all those are simplified because there are no perfect square factors of 3, 5, 11, and so on. But in that bottom row, 12, 24, 200, all those numbers are not simplified because we do have a factor of each of those numbers that is a perfect square. So in step 1 of this, we're going to rewrite each radicand below as the product of the largest perfect square possible and a number. So we had 12 in the warm-up, and we had written that as 4 and 3. We're going to write those as radicands, though. The square root of 4 times the square root of 3. And same thing with 18. We're going to write that as the square root of 9 times the square root of 2, all divided by 2, and so forth. Now in step 2, once we have those written, we're going to simplify it. So then when we have the square root of 4, that's just 2. So our final answer is 2 square root of 3. Now 3 is a prime number, so that's cool. No real factors of it other than 3 and 1. But the key is that there's no perfect square factors of that number that's left. So our final answer for that would be 2 root 3. When we have square root of 18, we're going to rewrite that as the square root of 9 square root of 2 over 2. The square root of 9 is 3, so it becomes 3 root 2 divided by 2. And we can't simplify that square root of 2, and these 2's definitely don't cancel, so that's about as far as we can go. Let's look at letter E, which I think is a little bit more challenging one because of the fact that we have that 5 out there already. So when we take 125, we can break that down into 25 and 5. Again, radicands. The square root of 25 becomes 5. So we're going to have 5's all over the place here. And this is what we essentially get. Now that number that was already out there, we multiply by what we bring out. So if we had 5 times 5, that's going to be 25 times the square root of 5. And then in F, we had root 108 over 12. Square root of 108 we said was square root of 36 and square root of 3. The square root of 36 is just 6. So at that point, we aren't done, though, because we can actually simplify the numbers that are outside the 6 and the 12. We can take a 6 out of each of those, giving us the square root of 3 divided by 2. So then in the next activity, we're going to say, all right, now that we have these numbers, we know how to simplify. Let's put it all together with multiplication. So we have 9 times the square root of 24 times 5 times the square root of 125. And we're going to simplify that product. Well, there's 2 ways to do this. One way to do this is to take the numbers that are outside, multiply them together. Take the numbers that are inside, the radicands, and multiply them together. And then simplify from there. But here's the concern. If we had 24 times 125, that's a big number, a huge number. And it's going to be very difficult for us to find perfect square factors of that radicand. So it might make more sense for us to try and simplify the 24 now and simplify the 125 now and see where that takes us. So when I have 24, I'm going to write that as the square root of 4 and the square root of 6. And if I have 125, I'm going to write that as 25 and 5. Well, square root of 4 is just 2. So the 9 times 2 becomes 18, square root of 6. And square root of 25 is 5, multiplied by the 5 that's already there, and we get 25 root 5. At this point, we're going to multiply those numbers. We're going to take 18 times 25, and terrible, I'm going to have to use my calculator for this one, but it is what it is. So 18 times 25 ends up giving me 450. So when I multiply the outside numbers, I have 450, and the inside numbers would give me the square root of 30. Again, thinking of factors of 30, 4 doesn't go into it, 9 doesn't go into it, 16 doesn't go into it, 25 doesn't go into it. So I have no perfect square factors of 30. That is simplified. So the alternative to this was to take 9 times 5 and multiply those right now. It gives you 45. And then take 24 times 125. I want to say that's 3,000. I'm right, it's 3,000. And then simplify from there. So then we'd have to find factors of 3,000 that are perfect squares. I think that's a little bit challenging to do. All right, so then let's look at 30 or number 3, because we have that negative introduced now, and that's going to change things a little bit for us as far as how the answer looks, but it's not going to change our process. So we know that 63 we can break down. That's going to be 9 and 7. And we know that 162 we can break down to 81 and 2. And if you don't recognize that one right away, just start thinking about this. All right, 162 is an even number. What would happen if I divided by 2? And if I did, I'd get 81. Well, that's a perfect square. We know that one. So then the square root of 9 becomes 3. Oop. And then we're going to multiply by the negative 12 that's there. That gives me negative 36 square root of 7. Square root of 81 is 9 times 3 would give me 27 square root of 2. So I'm going to take 36 times, or negative 36 times 27, which gives me negative 972. And then 7 times 2 would give me 14. And 14, there's no perfect square factors of that. We have 4 and 9 are the only perfect squares smaller than that, and none of those go in. So it doesn't quite work. So in the next part of this activity, maybe we have to go a step further. So let's take this, this will be our last one here, 2 root 45 times square root of 48. So 45, I'm going to break that down to 9 and 5. And 48, I'm going to break down to 16 and 3. Square root of 9 is 3. There's already a 2 out there, so that becomes 6. Square root of 16 is 4. Oop. I did that right. There we go. And then we multiply those. So again, multiply the outside numbers, we get 24. Multiply the inside numbers, we get 15. And I lied, this is actually not going to be our last one because I thought it was divisible by something that it totally isn't. Let's take a look at number 4. We have 3 root 50 times 3 root 32. So we're going to take 50, it's going to become 25 and 2. And 32 becomes 16 and 2. So 25, we know that is 5 when we take the square root, times 3 is 15. And square root of 16 is 4 times 3 is 12. So I can multiply 15 times 12, and that's going to give me 180. Multiply the square roots, and you get 4. This is where we might have to go a step further, because when I look at that radical, or sorry, the radicand that's left, it's 4. That is a perfect square. So I'm going to simplify that further. When I take the square root of 4, I end up getting 2. So it becomes 180 times 2, which would give us 360. So the key is that when you get to a product and you're done, or you think you're done, you want to look a step further and make sure that what you have left has no perfect square factors. And that's how you're going to simplify radicals. Take out your perfect square factors, whether you're multiplying, dividing, or whatever.